Hi, my name is Becca, and this is a video about the exciting new ways in which polymers can be used in the pharmaceutical industry, in particular potential new cancer therapies including nanopolymers. But first of all, we must review what polymers are and how they are derived. The Oxford definition of a polymer is as follows: a substance which has a molecular structure built up chiefly or completely from a large number of similar units bonded together. For example, many synthetic organic materials used as plastics and resins. And what this is essentially saying is that a polymer is made from many small subunits known as monomers, which chemically bond and join together to form a long chain, aka a polymer. There are two types of polymer. These are synthetic and natural. Synthetic polymers are man-made and created in the lab, for example nylon, which is used in clothing, in particular tights. Natural are, as the name suggests, found in nature, for example cellulose, which is a major component of plant walls. Now we are ready to look at polymers within the pharmaceutical industry, and already polymers are widely used and have many functions, from binders in tablets which hold the components of a drug together, making it compact and difficult to crush, to flow control components, to film coatings which prevent people from experiencing the unpleasant taste of a drug, to drug control characteristics. However, they are also being used to develop new and exciting kinds of drug therapies within cancer research, which is what the rest of this video will be focusing on. Polymersomes. Polymersomes are a synthetic nanopolymer. This means they are man-made and synthesized within the lab, and nano meaning extremely small. The polymer chains synthesized are used to create bi, meaning two, layered vesicles. Vesicles meaning they are essentially making these double-layered spheres, which are hollow. And the polymersomes we will be examining in the rest of this video biodegrade in acidic conditions, making them pH dependent. However, others can be thermosensitive, meaning they biodegrade at different temperature conditions instead. But it is this acidic biodegradable property which makes polymersomes a potential candidate for new cancer therapies. Before discussing the ways in which polymersomes could potentially be used to administer cancer drugs in the future, we will look at some of the drugs already used to treat some cancers. Taxol and anthracycline doxorubicin are two cancer drugs commonly used in chemotherapy to treat a wide range of cancers including breast, stomach and ovarian. Their primary function is to stop cancer cells from being able to duplicate and therefore prevent tumour growth. However, they come with many nasty side effects, including but not limited to joint pain, irregular heartbeat, nausea and alopecia. This is because when the drugs are administered straight into the bloodstream, they not only attack the cancer cells but the healthy ones too. Hence, scientists have been investigating ways in which we can administer these drugs whilst limiting the side effects and still promoting efficiency. When this was investigated, tax and dox was given to mice with tumours. The tax was embedded within the actual molecules which made up the polymersome vesicle shell. Dox, on the other hand, was held within the hollow centre so that it would not be administered until the actual polymersome biodegraded inside the acidic tumour cell. It was discovered that the two drugs spontaneously formed a cocktail, which led to better tumour regression than either of the drugs alone. It was also found that the polymersome drug cocktail carried the drugs more efficiently to a tumour. It's because of this that polymersomes hold such great potential within future cancer therapy. The polymersomes within this experiment were developed by Friel et al. Using the core polymers PAG, PLA, which can be seen at the top of the screen, and PAG butadiene, which is the two separate photographs at the bottom of the screen. Now, throughout this video, you'll have heard me talk about polymersomes as something that could be used in the future. This is because there are still many challenges to overcome before they can be actively used within cancer therapy. The first being that they are yet to be approved by the FDA, which means that clinical trials have not yet begun. Unfortunately, methods for large-scale and reproducible production is lacking. And also they are a very new technology, so there are few examples to compare the rate of success to, and therefore clinical translation is proven to be rather difficult. However, they still hold great potential and are being researched and developed as we speak, so hopefully there will be some breakthroughs in the coming years. I hope this video has helped and been informative. Thank you for listening.